So we are going to talk about life cycle. So if we're already talking about cycles, I want to say that for me, this is really a life cycle in the sense that Rafi was a teacher of mine when I was doing computer engineering about 30 years ago, even longer than that. And Rafi taught me computer networks, and it serves me a lot, as you will see in the next few slides, in life. So it's an honor to be here, and I want to tell you a little bit about what we are doing in Ravello, but before that, I want to give you a background where we are coming from. It will better explain what it is that we are doing. So this is not our first company. We had two networking companies, Pentacom and Pcube. One was doing DPI, deep packet inspection, and the other one was in layer 2 networking. These two companies was acquired by Cisco, one in 2000, the other in 2004. But the more relevant is Qumranet. In Qumranet, like the Qumran cave, we did KVM. Anybody heard about KVM? Good. So KVM stands for keyboard video mouse. No, not really. I think you know by now that KVM stands for kernel-based virtual machine. It's a bad name that, in my opinion, Avi Kiviti, the one which is behind it, he was the maintainer till about 2 years ago when he started his new company, gave the name, and he insisted on keeping this bad marketing type name. What we are doing in Ravello is based on the work that we have done in KVM. I will try to convince you and explain to you how these things are related. So let's talk about the problem before the technology, the problem that we are trying to solve in Ravello. What you see on the far right bottom side, you see the slide that pretty much all IT is trying to solve today. You see an application that's running in a private data center, and everybody wants to be able to move this application to other environment, whether it is private cloud, public cloud A, or public cloud B. This is the challenge. It's basically, I want to run any application at any stage of its development, whether it is development, QA, staging, production. I want to be able to run it on any of these environments without changes. I'll touch on it later on, in a way that allows me to concentrate on developing the application as opposed to making the DevOps type of work of adjusting the application to the infrastructure. So I want to be able to have like a compiler that does take my application without me having to worry about it and maps it to any of these clouds. The challenges in doing that is that the environment that you're going to run on is different. If you're running locally, most likely today, 2015, most of the data centers are virtualized, so you're running on VMware. This is a different environment that you will find in the public cloud, like in Amazon. It's running on Zen. If you go to Google GCE, it's running on KVM. Not only the hypervisor is different, the environment from IT perspective is totally different. One of the big differences that you will see is that in the public cloud, you don't have layer 2 networking. You don't have support for layer 2 networking. There are other differences. I will not get into those. In order to solve this problem, you have to come with a special technology or special approach. I'll show you the solution in a second of how this problem is being solved or being addressed today. But before that, some of the requirements are here on this slide. The first one is the mobility. Basically, being able to take a running application and move it as is to a different environment. And this is a big one. I'm not talking about doing a porting or massively rewriting the application, but take the application as is and move it. When I say application, by the way, I don't mean something simple like Word or, Microsoft Office. I mean an application that comprises a few hundred virtual machines with used storage. I'll show you some examples if we have enough time. While you're doing it, you have to worry about SLA, service level agreement. You have to worry about security, governance, policies. You have to talk about how do you charge for it. It has to be self-provisioning, and the management should be the same regardless of where we are going to run it. Here are the few solutions that exist today. The first one is massively porting the application. So this is, you bring a consulting services, system integrator, or you do it locally. The other one is basically rebuilding the application and using configuration management tool like Chef and Puppet to port the application and be able to adjust it to the different environments. There is the PaaS, Platform as a Service environment. Basically, you write your application to run on a certain platform, and you're assuming that the target cloud or the target environment that you are moving to has support for this PaaS. And then you have the Ravello way. So let's talk about the Ravello way. And before I explain to you what we do and how we do it, which is more interesting to this crowd, I want to talk about the concept of a capsule. So this picture shows you a typical application. You can see here a collection of about 9 virtual machines, storage, and a few virtual appliances like load balancer, firewall, and routers. What we are doing in Ravello, we are encapsulating all these elements in a new entity, which we call the Cloud Application Capsule. And we have an application that's self-contained. So everything that's related to running the application, it's sitting within this capsule. So things like the virtual machines, things like the storage, the overlay network, the overlay storage, and some dynamic rules on how the application should behave dynamically are part of this capsule. Okay? So we have a way to take all of this and take it into a new monolithic entity, which we call a capsule. Now, the capsule itself doesn't have any hardware element. It doesn't have any special changes compared to what you are used to have today. In fact, the elements that you used to have in the past to communicate with your virtual machines, like IP addresses, like storage addresses, remain the same. So in this picture, you have, for example, a firewall. It can still talk to a queue service that exists on a local cloud or other database analytic services. Things will continue to communicate the same way that they communicated before, including communicating with elements that you left in your private data center. Okay, so if you have, for example, user database on your private cloud, it will still communicate with the capsule and it will be managed the same way. So this is the basic elements that we have and the basic building block that we are providing IT. And when we are providing to them the ability to look at the application this way, there are very powerful operations that they can do on this capsule. Before I go into the operation, I want to give you a feeling on how big this can be. So the biggest design that we have run, the biggest capsule that we have run, is about 300 virtual machines, 80 terabytes of storage, 40 VLANs. But hey, VLANs you cannot run in the public cloud. Okay? So it has 40 VLANs, it has 8 different virtual appliances, and we are able to run with our technology, we are able to run it on any public cloud. The alternative of doing it the other way was to build the application, basically build it from scratch, replicating a data center and being able to have a copy of the production environment. In this case, the use case was certification. I'll touch on it if I have enough time on the next slides. So this is a real environment. The company has been around for about 4 years. For 3 years, we were busy developing. And for the last year, we are actually starting selling this service. So once you have the application sitting in a capsule, there are very powerful operations that you can do from IT perspective. This is the agility. You can easily create a copy of the application. You can take a state. You can restart the application from a non-state. You can compress the application if you want to save cost. Or you can expand it and allocate more IT resources to it, like CPUs or storage, if you care about performance. All of this we are doing without changing the application whatsoever. So how do we do this? Before I go into this, we are innovating on technology, as you will see in a second, but we are also innovating on a business model. We don't have hardware. We don't have data centers. We are running over the top. So you can look at Ravello like a virtual cloud provider. So same thing like there are virtual mobile operator, like in Israel, Hot, or other virtual operator. We are virtual cloud provider. We are running over the top. So we are running on top of other people clouds and other people infrastructure. As opposed to the mobile operator, we don't need support from Kahlon, from the regulator or from the government, because we provide additional services, as you will see in a second. So how do we do this? What you see going left to right, you see the evolution of virtualization. So on the very left side, you see the OS running directly on the hardware. And then came the hypervisor that sitting between the hardware and the virtual machine itself. Actually, about 9 years ago, I did a presentation when we just started the Kumonet in the Technion, explaining about how to do virtualization. So pretty much we are facing the same problem, but now we are taking it to the next level. So the next level is the new layer that you see there. It's called HVX. HVX stands for Hypervisor Extension. Okay, it's a nested virtualization, so people are learning operating system. It's called nested virtualization. It's virtualization within a virtualization. This layer looks to the hypervisor like a VM, like a virtual machine. To the virtual machine, it looks like an hypervisor. So we can take any virtual machine and run it on any hypervisor. Now, this is a big statement. I can only say the things that we are testing. So right now in regression, we are running a combination of about 400 combination of hypervisors, mainly 4 hypervisors that exist today, and VMs. So we can run Linux, we can run Windows as guest, and we can run weird operating system like BSD, Solaris. We can run DOS even. Very interesting. So this layer, the HVX, is like the crown jewels of Ravello. We can do much more than that. As you can see, this layer is sitting between the hypervisor and the OS itself. Because it's sitting in such a strategic layer, it intercepts all the I/O that's going from and into the VM. And by doing that, we can provide the glue that connects the application together. So things like networking, you have here the overlay network that's being created by cross-connecting the HVXs. The HVX is used here as a building block to build the capsule, okay? So we are cross-connecting it with the GRE tunnels. Within the GRE tunnels, we can emulate layer 2 and layer 3 networking. We can do the VLANs, we can do the broadcast, we can do the multicast. So when I talked to you before, I mentioned overlay network. People call it SDN, software-defined network. I want to explain here that this is a different approach than what you have seen in previous examples or previous lectures, where people were talking about SDN, software-defined network of the data center. In our case, the SDN, the software-defined network, goes together with the application, okay? So the application is self-contained. You can map the very same network on any cloud that supports layer 3 and get the same networking effects that you had before. There are performance issues. We can talk about them separately, but we take those into account as well. Same thing we do for software-defined storage. This is how we do the storage. So once you have the application encapsulated and you're ready to deploy it, there is a magic compiler that we provide that goes and kind of take your restriction and constraint into consideration. You can look at it like a compiler. The compiler will see what's the best match between your requirements and the current available clouds, and will do the best mapping. The first thing after the decision, it will take the provision several virtual machines, let's call them host VMs. On those host VMs, it will bootstrap our HVX, and then it will bootstrap the VMs of the user. While doing this, it will configure the networking, the storage, and all the other things. I want to mention a few words about the technology that we are using here. Nested virtualization is not new. It has been around. In fact, one of the first works was done here in IBM, Turtles project it was called. The unique thing about our nested virtualization technology is it's done with binary translation. So we are doing binary translation. There is a paper. You can go and find it on the web. If you can't find it, send me an email. The important feature of this nested virtualization technology is that we cannot rely, because of business reasons, on the cloud provider. So we cannot change the hypervisor of the cloud. We have to do everything that we are doing, all the magic that we are doing, pretending that we are a regular OS. So when we are doing it, we have to take care of the privilege of the operating system of the guest, the privilege of our HVX, and then the privilege of the user space of the guest itself. So this is part of the magic, and that's why we chose to do it with nested virtualization. There is coming support for nested virtualization in hardware, just like there was VT for level 1 virtualization, if you want. We cannot use it today because it's not available in all clouds. It's relatively new hardware in servers, and because cloud providers are not likely to enable it anytime soon because the complexity and the security issues associated with enabling this type of feature. Everybody is going to ask about performance. This slide is taken from initial release that we have done about 2-3 years ago. We showed performance. The higher the bar, by the way, the better performance we have on different benchmarks. We have improved performance tremendously since then. There is a guy here, Boris, that's helping improve this performance, and this is a work that we are constantly doing. Now, I told you already that what we have done in Ravello, we basically took virtualization to the next level, and we have done nested virtualization. So you can imagine what we will do, like mathematician, you have solved the n problem, you're going to solve the n+1. The n+2 problem is going to be what you see here on the right side. So on the right side, you can see, rather than running a regular VM on the HVX, we can run an hypervisor. So this is additional level of nesting that we can offer. By doing that, we can run things like KVM in the public cloud, or we can run ESX in the public cloud. This is a very powerful approach. The overriding performance here, it's unchanged basically relative to the previous n+1. So this is n+2. We can go into technical details why it's so effective. The n+3 is going to be more difficult to do. I don't think there is right now a good reason to do it, but I will not say anything because this was my initial reaction when people back in Kubernetes days came and say, let's do n+1 virtualization. So we see the n+2 right now. Everything that we do can be done with API, and most of the Ravello user are using our APIs in order to interact with the system. This is a summary slide that summarizes what we have done in Kubernetes, and this is what we are doing in Ravello. So on the left side, you see virtualization. Virtualization is doing 3 things to the operating system. It's making the operating system monolithic. In one file, you have the binary executable data configuration files. Once you have, and also it's detaching the operating system, the VM, from the hardware itself. Once you have the separation and the monolithic notion of the VM, you can move the VM around from one cloud to another, from one machine to another machine. That's called migration. In Ravello, we are doing exactly the same thing, one level up. Rather than dealing with a single VM, we are dealing with an application. Rather than dealing with a single piece of hardware, we are dealing with a cloud. So we are making the application monolithic. You can describe the application in a file. You can detach it from the cloud that it's currently running on, and then you can move it around from cloud to cloud. These are some of our customers. I want to show you 2 use cases that we are using it. So let's talk about Reddit. If you go and take a Reddit class today, for example, you want to get training or official class on OpenStack, most likely it will run on Ravello. So this is like a virtual lab that Reddit has created on top of Ravello. They can get any number of copies. All the copy of each one of the setup is identical, and each student can go and connect wires on the fly without any changes. Another one is Checkpoint. Checkpoint is using us mainly for training and sales kickoff. They had the event where they had 1,000 SC. Each one of them got a complete environment, 5 virtual machines, and was able to do the testing just like it would be in a real physical lab that they would do otherwise. Security is one of the best examples on what you can do when you have such an IT agility power. It's very easy to use it for war games, to simulate attacks, prevention, and training on security. We are not going to stop in sales enablement, test, and development. We are going into production, but I ran out of time to tell you about this. So I guess we have time for questions.